Welcome to the story of Homer, from Inception to Motorama 2023. Homer was built in 2022, so this shouldn't be too long of a story this time. Bookmarks are in the description. I'll be explaining some of the background of Homer and going over a summary of his design, then going into a detailed explanation of each of the main areas and why I did it that way, then on to Homer's debut at Motorama 2023. Homer is a 30-pound full combat rammer robot, or as I will frequently refer to him as, a bashbot. I chose this style because I thought it'd be fun. Rambots are more exciting than wedges. Several spinners run systems that can't handle a ton of abuse that rambots deliver, and I needed driving practice. So this is Homer competing for Motorama 2023. He's basically a bash bot. We got a 1/4-inch AR500 bash shield at the front. We have forks at the back. So basically the idea of Homer is to actually take from season 3, episode 8 of The Simpsons, the Homer They Fall. It's the boxing episode of Simpsons where Homer's strategy is to have your opponent get tired from over-punching and then nudge them a little, where this is having to absorb the hits and then nudge them with the forks after. So basically the idea is going to be that I'm going to be intentionally taking hits to the shield at the beginning to hopefully burn out whatever weapon motor they have, and then tossing them around with the forks using control for that. So, going for aggression and control and hopefully winning a match like that. I've gone with a wood frame because I want to try that as well. Just with the idea of, if you have 1.5 inches of wood, is that going to be sufficient? Just because, for that you could also get like about, I don't know, I think maybe 5-ish mils of steel. Like, is that going to be overall better? And I mean, considering like the base frame here is only like $5 to replace, cost wise, I cannot worry about that being an issue at all. Like, I don't have that little bit in the back of my mind. The drivetrain is, they are 775 brushed motors, which will be interesting to contrast. I haven't used brush motors at this weight level before, so it'll be a nice contrasting comparison to Addle, who's always been brushless and the only other one I've competed with 30 pounds at. So yeah, basically the motor will go to here. This is actually PLA pulley, so basically we've got dead axles for the wheels, and then the motor here is a live drive, so it's going to drive each of these banks. The wheel assembly will be in another part of the video, which explains how it works, but basically it's a hub that bolts into these wheels, but that removes the shock out of like the more weaker plastic parts. We've got a battery box here. I got steel plates that go underneath and above it to absorb, impacts that go directly towards the battery, just because otherwise, it'd be easy to burn this whole thing down. And otherwise it's just basic, simple 2-motor drive, 4-wheel drive robot. Yeah, just with the idea of, keeping it cheap, keeping it simple, and seeing if it's just a blast or if this is a terrible idea and never use wood. We'll find out. One thing I forgot to mention is that Homer's center of mass and center of rotation are aligned for maximum mobility. Alright, so let's talk about Homer's chassis. So, obviously, it's made of wood. And as mentioned earlier, the reasons I'd chosen for it were that it's cheap and it has a good strength to weight ratio. There's actually more than that to it. When I'm using wood, it's easier to make components for it. It's easier to replace components for it. I mean, after all, nothing will get bent out of shape. Things will just kind of break and be unscrewed and put back in. And there's no need to tap anything in it, like tapping screws. Also, wood may work as a blade of armor. The wood is soft, so they won't be able to get huge bites on me. It'll just have little bits that chunk off. At least that's what I'm hoping is going to happen. And of course, again, that the pieces are easy to replace. So Homer is made out of surgical 2x4s, which are actually 2x3s. This was allowed for a pretty good height because the gearboxes are 1.5 inches tall, which gives me 1/2 inch on either side. And since I was using 775s, they stick out a little bit. And it gave me also just more room to squeeze stuff by the motors if I need to, like wires and whatnot. Homer has 2 entire chassis for this competition because it was cheap and easy enough to make. So the first one's actually built with this. This is the 2x3s that Home Depot sells. Both these are like a spruce pine fir, like mixed blend, whatever. But like Home Depot stuff was more expensive and it felt a little lighter. So for the second stuff I did Rona. When building the chassis, I strengthened, or the frame I should say, I strengthened it by adding dados into it. So all throughout the chassis there are dados cut into it where the pieces can fit in nicely to each other for basically free strength and rigidity, so you don't have to worry on the screws doing all the work, or the fasteners I should say. The top armor is made out of Baltic birch, purchased from Home Depot, but it was still it was better quality than like the cheap plywood you get. The thickness of this is a 1/2 inch, which is actually 11.5 mils in this case. And so Homer just has those top pieces. They just bolt in at the top and the bottom with a ton of screws. I think Homer is fastened with over 100 screws. And so yeah, Homer is basically a box frame with two internal rails that are used to support the wheels, like the drive system of it. The chassis does have a bit of a downside design in which in order for it to have a shield at the front and the forks at the back, the wheels end up being completely encased, which means that if someone were to get under me, they can high center me a little more easily, or I guess like just basically lift all the wheels off the ground because it won't be a high center necessarily. Those are the main concerns in the overall view of like the basic view of the frame. I'll have other spots in the video that mention more detail on little specific things I have in it. So for the construction of Homer, Homer is built with basically things being cut with a circular saw. The idea being that if I need to make replacement parts at the event, using a table saw or a chop saw might be better initially, but since I might have to replace parts of the event, having something that I can bring with me to the event is beneficial. It is just, basic cheap powered hand saw or circular saw. And yeah, having that just gives me the flexibility to make modifications or whatever as I need to at the event. I should also mention that I'm not much of a woodworker, so one of the reasons Homer actually has two chassis is because the first one was the learning one where I, fumbled around and figured out what techniques work best. And then Homer's second chassis is what becomes the primary chassis, which, has a bunch of the mistakes learned from and ironed out already. So while the bot's going to be pretty well secured from horizontal hits, the internal bracing with the dados right here, the side bracing here, which will all be supported by screws as well, I started getting concerned about vertical hits doing too much. I had originally planned for a screw to go in here, but it doesn't feel like it's going to be strong enough. So what I ended up doing is I drilled a hole in here and ran a 3/8 inch steel dowel through here into here, and hopefully that'll just give that extra bit of confidence to take a vert hit right on and not have this front piece just tear off, because the metal plate's going to be bolted onto here. So I imagine the worst force that this can take would be a vertical strike, and since that's quite common, this extra precaution looks to be the right way to go. So now to talk about Homer's weaponry. So at the front of Homer is his bash shield. The bash shield is solidly fixed to the frame. This was done for simplicity, like it saves time, cost, all that kind of stuff, but also because I believed it would be more durable than if I'd used a hinged setup. Well, this has almost no clearance here. The other one has already had some of the metal cut off to make a little bit more clearance, just because this is just a tad too low to prevent it from getting high centered. I added this little hole in here in case I needed to put a little stub to stick out to stop Homer from getting stuck on his face. But I found that in testing, I was able to rock the wheels back and forth enough to knock him down off his face. So I'm going to be leaving that out for the tournament. I'd considered various other ways of attaching things onto this, like having some hinge stuff on the front, but I left that out for this to save time and effort. Moving on to the other side of Homer, we have the fork layout. So basically these are 8 forks. Yes, both of these are, both the Shield and this are AR500. These forks actually went through several iterations. So basically the idea with the first one here was going to have that I had the bumpers built right into the forks, but in testing I found that the clearance was getting too tight. These brackets that hold it together are drilled by hand, so just my imperfections made that not reasonable. So I cut them off, and then I switched again to have more of a point and have flats on it. And then these are the final ones, which are just a longer version of this previous one. They're designed in a way such that they can be very easily removed. These bolts on the edge can just come straight out, and these ones here, they can come out enough that these forks can be pulled out, so they can be very easily serviced or removed if needed. I've added these bumper things in here. They're just basic PLA prints. The idea is to prevent these forks from going up too high or down too low in the case of them being tossed around. And it's basically to prevent, the forks from, high centering the robot. I've printed a bunch of these brackets for Homer. They're actually the various sizes, and also we got some adjustability in here to try and fine tune them to be exactly the way they are. I'm aware that the plastic's going to likely break very easily, so I've just printed 20 of them and just plan to replace them as they get wrecked in each match. Obviously a better solution would be something made more of metal or whatever, but there's just not enough time to do that right now, so plastic is what's going to be. Homer's wiring is reasonably simple. We got the main battery pack that sits here. We have the main power that goes here that powers the motors. So basically this power line runs to each of the 2 speed controllers that are here, which run to the motors, and the switchboard is here. On the switch to the side here, this powers the microcontroller. The microcontroller is actually powered off of the balance lead of the robot because the microcontroller draws so little power that it's just fine to steal it from the existing battery. The microcontroller is just in here, taped and secured down. Basically, it's responsible for doing the mixing and also sending signals to this light. Like, not only is it powered on, everything's good, but it'll also tell me if the signal is lost and if I'm low on power. I designed the wiring for Homer the same way I do for actually most of my robots, which was just simple MS Paint stuff. I mean, wiring these robots aren't too complicated, so I can get away with it, at least at this time. But yeah, we'll see how the wiring holds up. I don't expect there to be any kind of real electrical issues with this. Homer's drive pulley is just printed as a simple two-piece setup, and then run 2 screws through to connect the two together, so I don't have to worry about printing with overhangs and stuff like that. I have a little recess in here to allow for a washer and bolt to go into the gearbox so that I can keep it constrained going outward if I need to, but I don't plan on doing it. It seems to be holding firmly enough. And I have, as you can see here, the keyway only partially done in, like it doesn't go all the way through. So yeah, the keyway only goes partially through there to constrain it from going the opposite direction and bumping into the other side. But since I don't plan on using this, I'm guessing it wouldn't have mattered either way. So I'm going to explain my entire wheel system right here. So to make the wheels, I have regular Bainbots wheels here, and I have this little jig I just attach onto here. It snaps firmly into place, and I drill the holes into here. That'll give me, a result like this. I then have the pulley, which is going to attach to it. Right now this is just printed in PLA, but if testing shows that this melts or whatever, I'll switch it to nylon. So I have 2 brass inserts. They go in here. They can just be pushed in by hand in case they need to be, the pulley is destroyed in a match and needs to be replaced. I can still do that at the event without needing special tools. The Arbor Press just makes it easier, so I have it here. So those go in. It's 2 pieces because they didn't sell a single piece long enough, so just bought 2 different sizes and put them together. Those will go together and look like this at the end. They stick out just a little bit on the end. This side doesn't actually matter because it doesn't go deep enough, but this will help if it bumps into the side of the frame here. That'll just be only resting on this part as opposed to the whole pulley. So anyways, this then connects just into here. It snaps in. There we go. Anyways, that's not all the way in yet. Anyway, it just pushes in like that. Easier to do with 2 hands. And then I just attach 6 bolts into here, and it holds it all together like this is a single unit. These can be easily removed by actually only taking out this bolt, so just once the lid's off, I can just take the nut that supports the shoulder bolt there and pop the bolt on, and then replace these if needed. Yeah, I had considered using just the Bainbots hubs initially, but it felt like the extra piece, like component plus the extra weight and all that stuff, just wasn't necessary, so I just went with a single piece plastic pulley. These just slide on here. So on to Motorama 2023, and the thing I want to do most there, besides eat a pretzel sandwich, is fight Beam. Beam's power and durability make it a great candidate to test out Homer's design and see if my take on the style has merit or is deadwood. Hopefully this will happen and go down like other similar fights of Whoops vs. Last Rites and Tombstone vs. Duck. This matchup will be great because Homer will either win or be turned into a pile of sawdust. Will I get my desired highlight reel fight? Let's find out. So now that we're at Motorama, the first thing to do is build spare parts for Homer. While we do have a spare chassis for Homer, we don't have any spare parts, and that'd be nice to have in case we only take some damage in a match. While Homer was originally built with clamps, guides, and extra careful measuring, these parts will be built with a couple measuring tools and cutting by hand. And overall, they look like they came out alright. So with that done, Homer goes off and completes registration, and the brackets are made available. My first fight is not against Dredrick Tatum, Beam, but in fact Nautilus. Nautilus is sort of a worst case scenario for Homer. It's a shuffler, so it weighs 45 pounds, and it's a powerful vert, which I'm concerned may smash Homer's face right off of him. Well, let's see how that goes then.
3, 2, 1.
Oh, box rush from Homer, trying to get that disc stop. Nautilite doesn't care. Nautilite up to speed. Kicks him right against the wall. Oh no, the wood, not the plywood. Sparks the forks on the backside of Homer dug onto the floor. Nautilite not quite strong enough to push through and make contact. There's contact. All right, Nautilite on its head. That was loud. Nautilite on top of Homer. Oh, good, it spins faster. Uh-oh. All of a sudden, no motion from Homer. 10. Oh, tap out. That's a tap out from Homer.
I tap out there because the robot dies 1 second after an impact, indicating a communication issue. Since Nautilus was facing my shield, I do fiddle with it for a couple seconds before hitting the tap out button. Before I died though, the match was actually going pretty well. Homer structurally took the hits like a champ, but did get stuck on its own chassis and the forks a few times. The plastic piece it's meant to contain the forks failing is no surprise at all, but it is nice to see the wood function as a blade of armor like it did when I got hit on the side right here.
Alright, so looking here, here's our failure point. We replaced the antenna and it works. This is the antenna that failed, and we're trying to figure out where there's even visible damage, and we can't really see it.
The black smudge on the crystal is just some residue from the electrical tape. The antenna was replaced and secured in the robot a little differently to hopefully mitigate against impact and heat issues. Homer's top plate and bottom plate take actually somewhat significant damage. The top plate is replaced at this point because there's too much damage on it. There's just cracks everywhere. I'm guessing the robot is twisting under heavy hits, and the frame is fine with that, but not the plywood. And while the bottom plate has some damage, it's not worth replacing. The front of Homer has some nice gouges in it, and that grade 8 steel bolt has quite the clean cut in it. This does chip Nautilus's tooth a little bit, so there's that. Oh, and the battery box cracked a little and was replaced.
Alright, so we're on deck to go next. Homer's had his antenna repaired. He's got a fresh lid on him, and we've removed stress risers in the corners. Hopefully that helps hold it together this time.
My next opponent ends up using their postponement, which I'm mentioning because if you're also like me and didn't realize this, you can refuse a postponement. I didn't, and doing so is typically viewed as poor sportsmanship, but it's important to know that it's not a guarantee. So for my next match, I'm fighting a Maiming. A Maiming is a multi-bot consisting of a lighter, tubular, forked pushing bot, and a heavier undercutting saw bot with saws for wheels. According to the rules, I only need to knock out 50% of the robot to win, so I just need to knock out the undercutter.
3, 2, 1.
All right, Homer, the much larger robot at this time, can bully these two around. In their last matchup, a Maiming had to fight Huggy, whatever it was, but they do not do well against large wedgie bots. Yep, they're just getting bullied 2 at a time. Oh, get him, spin the saw, you're on top, no! Oh, no. Like a bigger brother picking on his little siblings. Oh, Homer's going to deploy the spikes now. Although it looks like they're having problems moving with the spikes into the floor. Yeah. The little guy's doing what he can. He's trying. He's doing his best. Oh, no. Homer seeing if he can just hurl his body into a Maiming and stop it from moving. It's not that it doesn't have a weapon, the robot is the weapon. Don't see a lot of motion out of the saw half of. Yeah, we're gonna start a count out. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. All right. Your winner by knockout, Homer.
Okay, so Homer just had his match against a Maiming. Looks like we only took some scuffs on the top when we took them for a ride on our roof, and otherwise came out unscathed. He was clearly having drive issues, so like, it's just unfortunate that he didn't get to perform as well as he could. But also, a bash bot against a multi-bot is just going to be a hard fight anyway.
My next match is against Pipe Bomb. Pipe Bomb is a torque reaction axle bot. This means it uses the reactionary forces of its weapon along with its wheels in order to move. Its weapon weighs 14 or 16 pounds, which as a note is heavier than at least one BattleBot's spinning weapon, and has a tip speed of 160 miles an hour. So basically, this robot can hit really hard. Homer's rear forks are removed from this fight because they'll offer no advantage and they can certainly hinder. So let's see how this goes.
3, 2, 1.
Okay, so the question is it possible for Pipe Bomb to hit Homer? Pipe Bomb hits quite hard, but with Homer being so wide, he might not fit. Now, it's also important that Pipe Bomb, move. It's always hard to tell with Pipe Bomb. His weapon generates so much torque that he always tends to.
I start poking at him more and more aggressively to figure out how much it'll take before he hits me.
Anyway. Well, we answered one question.
Yeah, that much.
Homer learned a painful lesson. But Pipe Bomb not really driving. Homer just headbutting him. Oh, okay. Pipe Bomb on one wheel, gyroscopic dancing all over the arena.
2 minutes remaining.
Homer nudging, prodding, waiting for something to happen, trying not to accidentally drive in between again. Well, Homer's playing with his toys, not sure what to do. Pipe Bomb not able to really mount any offense. Tumbling around the arena. Homer shoves him back in the corner. Stay in the corner. I think Pipe Bomb might need more grip on their wheels. Ultra-high molecular weight polyethylene is that white plastic you see all over the place, and it's phenomenally tough, incredibly tough,
1 minute remaining.
generally considered to be the toughest commercially available plastic. However, also very slippery. You don't make car tires out of Teflon. Every time Homer thinks he might be in trouble, just shoves Pipe Bomb back to a wall. Oh, interesting. Pipe Bomb almost attacked. When in doubt, ram him. Ramming speed. Bonk. Yeah, this plays out about how we thought it would, where Pipe Bomb, when it's able to bring the weapon to bear, was very dangerous. However, Homer just a little too big, a little too agile. Pipe Bomb never really able to mount a defense. So we're going to go to the judges, and the judges are going to tell us who won that. Oh no. The fight is over, Pipe Bomb. Oh, how convenient.
So after that first hit, it was clear I had to be careful while fighting him, but also take every opportunity I can to shove him around, which I think I did pretty well, and the judges agreed, giving Homer the win.
Alright, so Homer just finished his fight with Pipe Bomb. There was one collision we had when I was shoving him at one point. He hit this, climbed it, and then bashed into the top piece here, which did take a good chunk of plywood out. It's unfortunate that he got the corner piece because I use these to like align it, but it's not a big deal. So yeah, Homer just needs to be recharged and put back in again.
Nope, Homer needed more than to just be recharged and put back in, which is why it's good to check the whole bod and not just charge the battery. The front frame had split right in half, but fortunately we'd made a replacement just that morning and swapped it in. Homer's plow fenders had to be bent back into shape, and both motors had come loose from their gearboxes. I was using the supplied lock washers, which I hoped would be enough, but nope, Loctited it is now. It's the next day, the floor is repaired, and my first match is against Nevermore. Nevermore is a wedge with a rear vertical spinner, probably best known for having this event happen to it last year.
Plywood floor sections and getting buried underneath.
Nevermore seems to have been modified to have more ground clearance, so let's see how it goes.
3, 2, 1.
Fight, robots, fight! Ooh, both robots very quick, right out of the gate. Homer trying to decide which side it wants to feed to Nevermore. There we go. Spikes underneath Nevermore, lining back up. So at this point, Homer is being a little more cautious. Now, Nevermore able to get to the side of Homer, but not able to do anything. Even though Nevermore has very good traction underneath that robot, or little spiky tracks working very well for traction. But if you're not underneath your opponent, you're not going to be able to push. He does get under Homer, takes him to the wall. Nevermore appears to be a little faster, a little more maneuverable. Trying to run circles around Homer. Homer being much more methodical, cautious in their driving. But both these robots pretty quick.
2 minutes remaining.
Homer backing away, getting some space, trying to get lined up again. Homer's spikes are just a little too sharp. Okay, takes Nevermore to the wall. Yeah, every time Nevermore goes up those spikes, Homer just takes him right to the kick plate.
I pin him into the wall there for a moment just to prove I can. I generally prefer slamming over pinning because it's more exciting and it has a better chance of breaking something. And since it looks like that previous slam just broke his side of drive, that worked out.
Homer's found the way it wants to win. Just keeps putting Nevermore back in the corner. The floor was pretty such a short time ago. Nevermore hoping that this spin move will manage to kick them off of the forks.
1 minute
Manage to
remaining.
throw themselves into the wall. A move of desperation usually. Uh-oh, he got dizzy, he got tired, he wore himself, he's all tuckered out. Uh-oh, oh, was that a tap out? That was a tap out.
Red square.
Okay, your winner, Homer! Woohoo!
So that match went well. Homer's turning out to be the best bot I ever built, or at least the luckiest. Homer just needs its batteries charged and then it's off to the next match against Ava. Ava's been having its name pronounced wrong a lot this event. To clear things up, it's named after the mechas from Evangelion, and is a fork-based control bot. Ava is faster, more powerful, and has longer forks than Homer, but Homer has more fine control movement and more aggressive forks when it comes to their contact with the ground. So, let's see how it goes.
Pay attention, this one's gonna be hard to judge.
1.
Homer immediately gets stuck in the floor. And so far, no definitive winner in the wedge. There you go. Homer getting underneath Eva, but then losing the wedge game to the floor. All right, Eva on the side of Homer. Interesting. So the triangular corners on the plow of Homer got stuck when Eva tried to push from the side.
It's at this moment I lock eyes with my reflection in the Lexan. Failure staring back at me. I go to reach for the tap out button, but I stop. But I can't give up now. I must get through this. I must get to Beam. I must defeat Guy I just met. So I hold on. I've never had to crab walk before. My forks keep catching on the floor, but I must persevere. I must get through this. But seriously though, this situation really doesn't look good for me. I have been in a match at a different event where crab walking towards an opponent was viewed as more aggressive than the regular driving robot, but I'm not betting on that being the situation here. Realistically, I think the only way I can pull off a victory here is if I can consistently get him with my forks before he can get me with his, and also that he has something fail on his side so that we at least even the playing field damage-wise. Well, let's see if I can pull off this 1 in a million
Get
shot.
in the corner. Yeah, I'm not sure what's up with the one-sided drive on Homer. It doesn't look like it's moving at all. This makes judging this match a lot easier at this point. Eva shoving Homer around the arena. Whee! Very zippy robot.
I should also take this time to mention that Homer's actually pretty safe electrical-wise in this situation. By that I mean the motor is actually the weakest and cheapest point. The battery and speed controllers are rated to handle constant current above the stall current of the motor. So I may let the magic smoke out of a motor, but I shouldn't burn the robot to the ground.
Eva puts Homer back in the corner.
1
Again.
minute remaining.
When they go fork to fork, not a lot of action. There you go. There you go, Eva. That's how you control a fight. Uh-oh. Homer's dead side of drive might have been joined by his other side of drive. Nope, it was just stuck. It's back. It will continue to limp around for the remainder of this match, it looks like. Oh no! Hoisted up on their own forks. Eva frees them. Well, that got a lot easier to judge than I thought it was going to be. Your winner, Eva!
So Homer fails at this point. I feel like it was the pushing towards the wall as opposed to the collision with the wall that actually causes the failure. Homer is traction limited, and I figured that would prevent this kind of failure from happening, but I guess I was wrong. It's a shame, because this fight would have been pretty fun if we both got to go at 100% for 3 minutes. Homer's right drive failed because the gearbox pulley had shattered. When placed together, the parts showed that the failure was, not surprisingly, right where the key interfaces with it. This was a risk I was concerned about while using PLA, but my only other option at the time was to print with nylon, and I figured nylon would be more likely to fail as it's softer so the key could push through it easier, but it wouldn't have failed this catastrophically. So I'm knocked out of the tournament. That's bad. But I got a top 8 spot, only losing to 1st and 4th place, and that's good. But I didn't get to fight Beam. That's bad. But there's still a chance for a grudge match, and that's good. But Beam ended up getting 2nd place, not giving me a chance. Can I go now? Simpsons references aside, I'm actually very happy with how Homer did. I didn't toss Homer into the Rumble because I need him for an event coming up somewhat soon and didn't want to have to rebuild him. My top moments with Homer at this event were 1. Knocking over Nautilus and then slamming him into the wall, and 2. Replacing the front frame of Homer with a part I'd built right at the event. Both of these were excellent examples of Homer's build and design strengths showing through. So that wraps up Moto, and now we're on to the future of Homer.
So now to talk about Homer's future. So these will need to be reworked. That's not surprising. I'm considering a few options. One is just to replace these with a metal component, make sure they're trimmed to the right size. And another would be adding stubs and having these screws extend out just a little further so they act as the bumper themselves. And time permitting, I'll try to test maybe both of them even and see which one works out the best. The screws are nice and easy because you could just adjust them with little spacers. Homer's pulleys currently take a round shaft with a keyway in it, and I found that BaneBots actually offers a hex shaft option you can just purchase, so I'm going to convert it to that. I may also convert this to nylon at the same time. We'll just see how it's going. Nylon feels like it'll be the better choice at that point. To deal with the antenna issue, one of the things I'm hoping to do is cast everything in polyurethane. So basically get an Arduino. They stopped making the antennas I use, or I can't find them anymore, but these ones, there's these newer ones that are smaller. And then just grabbing a really beefy 3.3 volt regulator, putting it all together, casting it in polyurethane, and hopefully dealing with all kind of shock loads that way. And if I can cast it just right, I can leave the USB port still available so I can still tune the programming if I want to. The fact that the frame is made of wood worked actually quite well. I'm happy with it and willing to keep trying that going for a little longer. But the plywood doesn't feel as confident. I feel like switching this over to like, so this is about 1/2 inch, switching it to like 3/8 UHMW would weigh about the same, but give me a lot more toughness around here. Also, and this would require rework, so I don't know when I'm going to get around to it. Having the rear wheels come out the back would be better, just because the amount of times I got caught up when the front edge was like wedged up on a fork, whatever, was more than I would have liked. Like the idea of being able to back off and control myself if I try to run up someone's wedge or forks would be useful. And I think given the right kind of placement of the forks, that could work, because these could just be to the side and still have like some kind of guards, or build the guards into the forks themselves to prevent them from actually running up, being able to hit my wheels, but still having the flexibility that if the front end lifts up, it'll be able to pivot out of the way. If they lift me up from the back end, that won't help, but you know, just the cost of having a plow on the front end. So Homer's next event is actually going to be at the end of May. It's a sumo event. It's why Homer's designed the way he is and why he didn't go in the Rumble. Basically, I'm going to be using him again. For that sumo event, I'm going to keep the wood lid most likely, because I don't expect to actually be redesigning any of the chassis, and the wood will be fine for it. So Homer was designed always to be a twin-purpose combat and sumo robot, and so we'll see how he does as a sumo. A part 2 of Homer might not come out right after that. It might not be until after the next Moto event it competes in, but we'll see. So I hope you enjoyed part 1 of Homer's Odyssey.